Alright, we're looking at these that are decay models. They can be growth or decay. The way that we tell them apart is by whatever this base factor is right here. If this factor here, that is the base before the exponent is raised to the x power, is greater than 0 but less than 1, in other words 2/3 is in between 0 and 1, it's considered a decay. 0.5 here would be our base, not 3 times 0.5, but 0.5 would be our base. This exponent x only applies to this 0.5. So both of these would be considered decay, so that would kind of answer this question right here. Growth or decay, so we'll write those in, that these are both going to be decay. Okay. Alright, now the x-intercept on this, that's where it crosses our x-axis, and if we kind of look at this line here, here's a general idea of what it's going to look like. And it's going to get ever closer there, but never quite touch it. So in fact, on this one, there is going to be none. There is no x-intercept. The y-intercept. The y-intercept is where x is equal to 0. So all we're going to do is we're going to plug that one in, and we just have to remember that x equals 0 for the y-intercept. So if I take my 2/3, all raised to the 0 power, or anything raised to the 0 power is always 1. So my y-intercept in that case, I'll do it here in red, my y-intercept, x equals 0, and y equals 1. So my y-intercept is 0, 1. The horizontal asymptote, that's what we're dealing with here, is a line that it gets ever so close to touching, but never quite touches. In this case, it is going to be where y equals 0. Gets close to it, but never quite touches. And this one is indeed decreasing. Again, I'm a little sloppy there, but that's okay. And then the last one we've got to answer here is the growth or decay factor. And that's always whatever this base is right here. In this case, it's 2/3. So my decay factor in this case would be 2/3, 2/3. If you wanted to write that as a decimal, you could. I would take either answer. Alright, moving on to the second one here, and this one's just a little bit different than the first one. We've got to identify whether it is growth or decay, and it's all based on whatever this base is here. And this base is 0.5, which is between 0 and 1, which tells us that this one is a decay. Now we've got to look at the x-intercept, and the graph is going to still look really similar to this one here. So the x-intercept in this one is indeed none. It never crosses that x-axis ever. The y-intercept in this one, remember on our y-intercept, x equals 0. So we're just going to take this equation right here, and we're going to plug in 0 for it. So I've got 3 times 0.5, all raised to the 0 power. Well, anything raised to the 0 power is 1, but that 0, this 0 in this case, only applies to this 0.5, and this is where a lot of students tend to make a mistake. So you've got to realize that this 0 only applies to that 0.5. So if we do that, that's going to be 3 and 0.5 to the 0 power is 1. So this right here is equal to 3 times 1, which is equal to 3. So if we go down here to our y-intercept right here, remember that x equals 0. So when we write this as an ordered pair, it will be 0. And our y value in this case would be 3, and it comes from this 3 right up here. We're going to bring it straight down. Our y-intercept would be 0, 3. Horizontal asymptote on this one would still be y equals 0. It gets ever close to that one, and of course this one is decreasing. Okay, and the growth factor on this one, now again the growth factor is going to be whatever this number is, whatever this base. Up here it was 2/3, and right here it would be 0.5. So 0.5, and again if you wanted to write that as a fraction you could, it would be 1/2. Either way is acceptable.